Hello, welcome to another Great Cloud Basic training session. So this is session 18. We're talking about EEPROMs and all sorts of memories. Okay, EEPROMs et al. Okay, how do we get here? Let's get cracking. We set up the software at session 1. We got through to using tables yesterday and displaying table values on an LCD, serially detached. Today we're going to be doing memory, various types of memory. I've got a PIC, a 16F18313, could be any chip, I'm not fussed, and a programmer. It looks like this. Now, I've got this board, and inside of this board, I've got some memory, okay, and that memory is program memory, P I'll call that, and EEPROM, and they have very different uses. I actually have a third type, I guess. I have RAM, which you all know as RAM, okay. Now, what we're talking about today is programming EEPROM, which is long storage data that can be changed by the user or the program memory, which is also long term, but it can't be so easily changed by the user. It's firmware. Now, our use cases are if you want to put data for long-term storage, that might be configuration data. You could put that in EEPROM. You could put it inside of PROGMEM. Pretty advanced, but we'll show you how to do that. And finally, we've got these other two that are rather new: HEFSAF and SAF. We make it pretty simple to use all of these. Okay. So we're going to number one, we're going to read and write some EEPROM data, and then we're going to do some program memory. Then we're going to do and read and write some HEF data to the chip. Now, I'm going to change the chip at some point today because I'm going to have to. Now, I am looking at the code where we left it yesterday. This is session 17. I'm just going to program that up to make sure everything is working. Then we're going to look at the LCD because we're only going to use it very, very briefly. That's got my name on it. Oh yeah, it's got it. It's come up from the program from yesterday. Right. So let's just zoom back in on the editor. We'll just take a copy of this code down to here, put it into a new program, and I'm going to explain it very briefly this time. Define the chip and use option explicit to define variables. The next section is setting up the serial, the USR, the serial. I'm connecting that to a particular wire, and then I set up my serial comm speed of 115,200 BPS, and then I'm telling it it's a serially attached K107 LCD, and then I'm gonna I print some data out. So let's just make sure our little old program is running. Memory. Memories actually. Memory. We're just going to save that file. Take the default name and just save it. And then if I look at the LCD, we should see it change over to. Let me just do that. I've had just locked up the LCD. Look, okay. There we go. I'm not going to redo the video. Right now. What I'm going to do is I'm going to write some data to the the chip, but I'm going to be using EEPROM. So how do I do that? I use a thing called EEPROM. And EEPROM, if I look at the help for you, EEPROM, press F1, I get the help come up. And here it is. It says EEPROM, a location, and put some data in it. Location, and put some data in it. So what are these locations? Let's have a look at this diagram. Let's go back to PowerPoint for a second, okay? All right. Well, in PowerPoint, I'm looking at a couple of screens here. This is the memory map shown on the screen here. This nice diagram in the data sheet. And right down here, look, I've got EEPROM, and it sits at address F000 to F0FF, which is here. This larger diagram I've made for you, and it's 256 bytes. Well, you couldn't. If you wanted to, you could address these memory directly, but what we do, we make it very simple. This is byte 0, this is byte 7, Therefore, by simple math, this is byte 255, and we use that as the location address. We make it very simple across the whole range of chips using EEPROM. So let's go back into our editor here, and we're just going to edit that in and just put EEPROM. We're going to put it in location 0. We're going to put a hexadecimal value, because then we can compare and contrast it, called AA. I'm going to then read that back, but to read it back, I do need to declare a variable, and I'm going to declare that as a byte. And just to make sure that you don't think I'm sort of tricking you here, I'm going to set that to 0, and then I'm going to do an EP read, which is the same, almost the same syntax, an address or a location, and then a variable. And all I'm going to do is print in value as a hexadecimal value on our LCD, and then do a loop, okay? And program it. So that's programming it here. So what we're expecting to see is 0, 0 on the screen. Oh, I can see why, because I put EP write in here. God, that was a bit of a worry. EP read was what I meant to put in. And this is EP write is EEPROM write, and EP read is EP read. And now it puts the value AA, and it's got that off the chip. And if I power the chip down, it is retained. So how can I prove to you that's the case? So if I look on my desktop, I've got an application called PickKit, and I'm going to read the chip in. I'm going to read the value of the chips. We'll be covering programming tomorrow or the next day or two. And if you look in here, I know it's hard for you guys. If I look at the value there, it's set to AA. And that means that we've done it quite well. We've written a value. And if I write out in the program a whole series of other values, I'm not going to put them on the LCD. I'm just going to put them in here as location 1, 2, 3, 4, 5, and 6. And I'm then going to change the values here so that we can track them. 1, 2, 3. Oh, sorry. Just blew that one up. 3, 4, 5, and 6. If I program that out, I'm going to read it in using this other piece of software so we can see it. Okay. So if I go into my piece of software and I read in that piece of memory, you read it in. Oh, I'm on the wrong screen. Let me just zoom in for you. Let me just set it up so I can zoom in on there. No, I can't. So sorry. That says A0, A1, A2, A3 through to A6. So this value here is exactly correct what we put in here. So that's EEPROM. Writing to EEPROM is very useful. But let's do PROGMEM. Let's write to program memory. Program memory is definitely for advanced. You don't want to be doing this unless you know what you're doing. Okay, all right. Let's look at PROGMEM. Where does PROGMEM sit in the great scheme of things? Well, PROGMEM is here in memory. It sits at a location, and this should be a 5. It sits at location 5 through to 7FF, which is this little memory map I've drawn here. And you can write to any of the 2048 words. So you've got your program sitting at the top of memory, or it could be at the bottom of memory, depending which compiler you're using, but you've got an empty space in the middle. Let me show you that and prove it to you. We're going to go into that little application where we're reading the chip. And if we just cursor through to look at the top, we've got values in here. We can see values, and then as we cursor down, we scroll down, we eventually end up with 3FF, and that's the default value for chips like that. It's 3FF for the whole continuum. So let's just take a random location. I'm going to take this random location here, and we're going to put some values in this row here, and we could then read them back later on. That's what people do. This is advanced, but it's very simple with Great Cow Basic. So the location we're going to write to is 7F8. 7F8. So let's go back into our editor here. And how do we do this? Program write. And the moment I start to write program write, it tells me I need to have a location, and a value. So we know our location, 7F8. Oh, very good. 7F8. And I'm going to put the value of 55 hexadecimal. And all I'm going to do is read it out. I'm just going to, actually, let's just do a few, right? 9A, B, 6, 7, and 8. And I compiled it, but didn't actually program it. So let's do it properly. Now, the LCD is not going to show anything at the moment. Okay, all right. So there's no point of showing you that, because we're going to go to my desktop, look in here, and I'm going to read the chip back in. 55, 56, 57, 58. That's what we put in here. So we can read and write program memory. We can also do something very dangerous, which is we can overwrite the program. If I write to this particular area here where the program exists, I will break things. Okay, now we're going to look at another type of memory. By looking at PowerPoint, we have another type of memory. It's called HEF or SAF, okay, depends. And it exists inside of the program flash memory that we just saw, but it actually exists at the top of memory, okay? Now I'll explain this in a moment. So we've got our normal, this is a different chip look. It's a much larger chip, 16 384 words. It's a bigger chip, and they're typically 16F chips or 18F chips, and there's a block of memory at the bottom here that is actually called HEF SAF. If you want to read about this, please go to the datasheet. And it looks like this. It sits at the bottom of memory. They're typically 128 words, but they're not necessarily. You have to go check. And it's very hard to find this in the data sheets. So if I look at a data sheet for this particular chip, what's this? This is the one we're going to be using, a 16F 19156. It says where in the data sheet? Let's just do a search for the word HEF on the description. Oh, it says it somewhere. 256. Well, trust me, it's not 256, okay? It's 128 words. And it's very hard to find this stuff inside the data sheet, okay? It says here, for that particular chip, in another part of the data sheet, is 128 words. And that is the only reference to this type of memory. Let's look at it for an 18F chip. The only reference is at the bottom of a memory map. The only reference I could find in this whole diagram is here, in the whole of this document, the last 128 words. Now, why is this important? It's important because not all chips have EEPROM. Not all chips have any EEPROM. They only have SAF or HEF. So what I'm going to do over here is I'm going to unplug the program that we've been using, and I'm going to change the chip to one that has a different, that has some HEF, so we can have a little play. All right. In my desktop, I'm going to come into this user interface here. Let me get rid of that so you're not confused. And I'm just going to ask it to find me the chip. Well, I know it's a 16F 19156. And I can see at the bottom here, I've got a little piece of code that's appeared in my application here called HEF SAF. And if I cursor through it, the bottom of it is a slightly different color. It's got this yellow tint. And it tells me here that I manage it's an area between 3F80 and 3FFF. And I can write to that if I want to. And Great Cow Basic makes it extremely simple. So let me just show you how to do that. I'm going to cheat here and do it very, very rapidly. Okay, all right. I'm going to put my chip name in. For those who don't know, in this little piece of software, if I click the word device, it will put it in my cut and paste buffer. Option explicit. I don't really need to put that in for what I'm going to be showing you. And I'm going to put in HEF, and HEF is what I'm going to be doing. I'm going to write to HEF0 a value of 0x12. Now, I've got my programmer set up. I've got, will that actually work? Oh, I've got to save the file and program it. Oh, that chip doesn't support HEF according to this. Oh, it might be an SAF chip. Let's just try. It's an SAF chip. I've took the wrong one. And how can I prove to you? Because I haven't got a lot in here, but I can read the chip back in. I'm going to read the chip back in and see what happens in here. Look, I've got the number 12. Now, you might say, oh, well, how does this all work? You have to go and read the documentation on HEF SAF. The only reliable part of HEF SAF is the lower byte. So we write to the lower byte. So if I look at my program here, I'm going to put value 13, hex 13. I'll just zoom in for you. All I've done is I'm just saying to it, write these two values to the chip. Remember, I've changed the chip here. Come back into my software. Look at my desktop. I'm going to read the chip back in. And for those who can see, that says 1213 in the lower byte. Reading and write to memory using Great Count Basic is not hard. That's what we wanted to cover today. 16 minutes, bit of a long session, but let's call that a wrap.